Hello everyone, this is Sambo. Today I'm going to introduce new feature of Maca that interact with cloud service such as AWS, Azure, or Google Cloud. As a first session, I'm going to show how Maca can interact with Amazon S3 to store and retrieve HSM message. So now let's get it started. Before we move on, let's take a quick look about what we did before. As this diagram shows, previously, we could send custom message using management workstation UI to the ORM sender, and the ORM sender sent the message to the client. But we couldn't send previous HSM message through the request tab or even message viewer because we don't save the entire HSM message in our local database, which is SQLite, but we only save the HL7 messages header to show some information about the HL7 message that we sent or received. So before we implement the feature, we think about what will be a good way to reprocess or resend a previously sent message. So this is new interface with AWS S3 for HL7 store and retrieve. As you see on the top right in the middle, there's ORM sender that interacts with other services and the UI. Firstly, once a ORM sender receives HSL message, it will send the ORM message to the AWS ORM uploader that we will create soon. And that service will access to the AWS cloud storage. And that message is saved. It is ready to be retrieved. Then a user can access to the management workstation, and in the request tab, there's a specific button to show a pop-up, and this is plugin. And that plugin pop-up has a way to retrieve to the AWS cloud storage using the plugin service named AWS ORM Search plugin. That service is actually HL7 Cloud Service plugin. And that Cloud HL7 Search UI above here is dedicated to HL7 Cloud Search Service. So both UI and service are highly tied to work together, which means this HL7 Cloud Service is only for this UI. And in the UI, a user can provide search conditions such as date or application ID, and then it will return through the AWS ORM search plugin by fetching data from the AWS bucket to the UI's result set. And the user pick one of them if there is, and then that will be populated in the main UI's HL7 message chain. And then a user can process or modify the message and the process. And that will be sent through the ORM sender to the client's app. If the client's app wants the modified previous one, we can modify as what we just did. So please remember this overflow or this flow of the message exchanging. Then we will implement it from the AWS ORM uploader first. So before we implement, this is new feature. So we recommend you to download Macadamia and Macaron from the MS Store if you did it, and then you can play the new feature with these two services. And if you didn't watch previous video, this slide shows the what you needed to do in your Makasui side and Merge Connect side. So please review these steps, and this will give you what we need to begin with this service. Once you define what you needed to begin with, the first thing is set up the Amazon S3 local environment. Instead of directly accessing the AWS S3, we decide to use the alternative of S3, which is MinIO Object Storage Service. You can pull the image from the site, the Docker Hub site. I already downloaded using this pull command, and you can see that MinIO is there. And then once you download, and before you run the container, you need a certain kind of location that store the HL7 message. In my case, I created the specific folder under the Maca folder, and there's a cloud and AWS. So this location will be used WinIO's main location to store HL7 message. And that value will be in the Docker run command. So if you look at this, all the arguments, you'll notice that there is a section about the location. And also you need to provide the root user's username and password. So I put that one as well. And lastly, what port you will use to specify the web UI, which I will show you a little later. So let's start the container, which is MinIO. Once you run this command, you can see what is the current status of the MinIO by using this command. And it shows two sections. The above section is for API access information that you will use in your service. The bottom one is for the web UI information that you need to access the main storage service, which is MinIO. So we provided the Maca UI, web UI, and API with the same username and password. You can use this one, but you can also provide your own way. For this testing, we use this simple Maca user and simple Maca pass for username and password for both web UI, which is this one, and for the API side. So you can copy this one or from here as well. This is web UI that you will access. And the first thing before you move on is there will be no bucket at all. I already created, but once you install that one, you will see that there's no bucket at all. So you need to create the bucket, whatever you prefer. But for this testing, I specified the bucket name as this. So please specify whatever you prefer. And once you create this bucket, you are ready to go. And we can move on to the next stage, which is actual project development. Before we create the service, let's think about the project. To make separate from the existing project, which is the HL7 order project, we may create another project to work only for AWS S3. So we can name as a AWS S3 project to make sure this is for AWS S3 only. And we can specify the group as a AWS ORM bucket to make sure, okay, this is the AWS ORM bucket only. Which means whenever we create the services under this group, it will be working for ORM. But you can put all services right under the AWS S3 project, but it might be better to specify more detailed information and have a specific group. The next thing is actual create the service, which is in our case AWS ORM uploader. We can create this one with the request listener that requires an argument. In our case, this that could be HL7 message. So we can create this one right under the AWS ORM bucket group. And if you look at here, you can specify the argument. And we may set this one as ORM that expects the HL7 ORM message will be sent to this AWS ORM uploader. And you can access this variable by using underscore ORM. So in the steps, we may need to think about the how can we access the AWS S3, especially the bucket. So we need some kind of way to access the bucket. But in that case, we have to find the relevant SDK. In our case, AWS SDK.S3 will be required. So optionally, but it's not optional, it's actually required. What is this one as well? I already downloaded and added the DL in this project, so you can follow the previous session to how to do that, or you can use the tutorial to, if there's a tutorial button, to how to add that one. But after that, you need to use these two lines of using to in order to use those two library, and then you are ready to code. So after that, what we need to do is in order to access the Amazon S3 bucket, you need a special class named Amazon S3 client. This client is actually do everything that you relate to S3. Even you can create a bucket using this one. But in our case, we just need to upload and retrieve and download. So probably upload and download is for Amazon S client. We may need extra library to retrieve the object in the bucket. But for now, we are focusing on the Amazon S3 client. So we can create this one using these three arguments. And the last argument is also the class that we have to specify. Just set this one as a new instance. And if you look at it here, there are two properties that can be specified inside Amazon S3 config. So the first thing is from the Amazon S3 client's perspective is those two arguments, which is username and password that we will use what we created before. So you can use what we saw before, like this one. We set the same username and password for both API and web UI, so we can use this one. So please specify this one in this one. So you can change the username and password as you prefer, but please make sure that this one will be used in here as well. So we can use this one for Amazon S3 client access. So you can specify for three arguments of the Amazon S3 client. And the second thing is the third argument, which is Amazon S3 config, and it requires service URL as you expected. This is the service URL because this is API. We are going to use the API, so directly place it here, or maybe use the variable here. Doesn't matter. So you can put in here. But the second thing inside Amazon S3 config is region endpoint, which is not actually required in the MinIO because there's no concept of the region in this emulator. So we can just ignore that. But in actual implementation, you may need to specify which region you are going to access or reach. So if you go to the library website. Oh, by the way, you can also access the Amazon SD client class documentation here, and you can see the all available method and constructor. And you can look at this region point property. You will see that there is a section about the what is region endpoint and what you can choose out of this list. For example, if you are the West Coast, you may choose the US West 2, like near to Oregon, or if you are East Coast, and you can choose the West Virginia or something. So please specify once you access the real service instead of this uh, emulator. So for now, we're not using this one, so we can ignore that. And we just specify the Amazon client's instant instance variable. And the next thing is Amazon S3 client has the method that upload. This is the async method. Upload the HL7 message, but not just simple string, but thoroughly special object, which is object request. And then you can create this one as well using its internal property that I specified in here. So, so we have to provide these main three properties to populate the object request. So bucket name is already familiar with that we created for, and it's not we, I created before, and we can use this one to populate this one or just simply this one, yeah, whatever you prefer. And the key is need to be final later because we have to access the HL7 message using HL7 V2 library. But for the last property, content by body, we can use the arguments in the ORM, and then that is the parameter that passed, and then the parameter is underscore ORM. So you can use passed parameter to assign to the content body. So next to the content body, we still need to define the key. So if you look at the document, we can use this PID2 and MSH7 to specify the key. So what we can do is think about the file name inside a certain storage. Certain storage in our case is bucket. And the key actually means the file name, including the extension, in our case, HL7, sort of. So we can specify the MSH7 and PID2 to get the uh, to populate the file name, actually the key of a bucket. In order to use that, we have to use this library, HL7.v2, and then we need to use that library's class, which is message. And we can assign the message with the parameter, the ORM. And of course, we have to call the parse message to populate all the segments and field and subcomponent based on the passed argument, passed parameter ORM. And then we can access the each segment field component. So we can access the value using the PID7, PID2, flat 2, and MSH7 like that. So you can just copy to form the file name. We may just use the dash to separate each value. And lastly, we have to specify the file extension. In our case, let's say HL7 in lowercase. So this will be used to store the HSM message, and the HSM message is the just content, and the content file name is this one, the file name. So you can use this file name to populate the key, and this will be used in the later section. So if we look at this one, by the way, we may have to specify the first argument like this, and there's no actually necessary to provide the cancellation token, so it's still okay. So we can even get the response from the object async method and put in the Waka's result message property to show the result in the transaction view in the management workstation. So we just created the instance of Amazon S3 client to populate the HSM message in the specific bucket. But in this case, we may think about the Amazon S3 client instance because this AWS ORM uploader service will execute whenever the other service request or even the user request. So if this is highly demanding, like it requires to be executed 100 times in a minute or 100 times in a second or maybe 1,000 times in a minute, it will create AWS Amazon S3 client as many as the request comes. So we have to make sure that this Amazon S3 client needs to be only one throughout this application. Whenever any service is created and use this one, that service should not create another instance of the Amazon S3 client. So this Amazon S3 client should be shared throughout the application. But in this case, we cannot guarantee that this one is only one. So Maka provides a two method that ensures the single instance throughout the application. So Maka provides two methods, create singleton and get singleton. So by using that, we can make sure the creating Amazon S3 client is only one throughout the application. It requires the type, so we have to provide the type to be created as a singleton. So this is generic type, and then you can provide the access key for this object because we are going to use get singleton using this key. So please make sure this key is not error-prone type uh, string because we may type incorrectly. It won't access the expected class or instance. So we can put this name as the same in here. And then the rest are what we use in this area of the constructor. So we can create this one. So still have to access that one. So we can create this one, but still this one, make sure the single instance, but as I said, this will be executed as many as request comes. So we have to make sure that this create singleton needs to be called as minimal as possible. In that case, we can use the deploy section, which runs just one time when this service is deployed. It doesn't matter whether the other service requests this service, it is always running only once when the service is deployed. So this makes more sense than the other location to make sure this create singleton is called only once per service. So we can use this way to make sure only one instance is created. But the thing in this case is that we have to concern is there are two lines of code that is related to the credential, which is sensitive data. Once you look at the Amazon's documentation, you may choose a way to store the secret information in the secured location. So AWS provide certain guideline about that. Then you can look through and implement in your service. In most popular could be using environment variable in Windows case. So you can apply whatever you prefer, but for now we are not going deeper like that. So we just show how Maka can interact with cloud service. So we just put the only secret code in here as a hard-coded one. But again, you have to implement your own way to deploy this service as a production-ready service. But for now, we are just using this hard-coded one to create the Amazon S3 client object. So once you created that object in the deploy section, next thing is you have to access that object using get singleton. Of course, this is the same way, generic type method. So you have to provide the type as a generic. And then the next thing is, as I uh, stated, the important thing is getting the correct name of the instance. If you type incorrectly, like this way, typo, you won't access this. So please make sure that the name is always correct. So by using that, we can create and access seamlessly throughout the application whenever the service is added or undeployed. So let's try this one. Okay, this works well. So this service will upload the HL7 message once the HL7 message is delivered here. So the next thing is who will deliver or send the message to this service. In our case, ORM sender will be the one because ORM sender will receive the ORM message from, there's no service here, but from DICOM reader that generates HL7 message out of DICOM file and then send the HL7 message to this ORM sender service. So in here, we can pass by associating using this add service request. Once you click the button, you will see that the AWS ORM uploader, which is request listener, is available in this pop-up. And you can click that one. And in this case, we provided ORM as a string, which is ORM message. And then we have to call this AWS ORM uploader service. And this ORM sender message has internal object, which is message. And this message, which is HL7v2 libraries message object, has the property named HL7 message, which is the string value of HL7 message. And we can use that one to populate the ORM property like this way. And then you can just verify whether this works well. Good. And then we can send ORM message from the ORM sender to AWS ORM. But the interesting is that we don't have DICOM reader, but we have ORM sender tester as we did it before to test certain messages. So in this case, we are not using what we previously used because we need all working HL7 message, which should not be filtered or errored. So all message should be okay, but somehow it might be, uh, filtered message. But for now, we can make the all good status message. So we have four test messages in here. We're not diving into one by one, but the key point of these four messages is that each message has a processing date of the message, which means this message was sent that day, this day, today, yesterday, or something like that. So I set the first two messages with last week date. For example, the first one is May 29th. The second one is May 30th, which is last week. And I set the rest two messages with this week, like June 2nd and June 3rd. And along with that, I put this some kind of testable patient ID like P0001 to P0004 as four messages. So by using this one, we will send message to the Merge Connect, and at the same time, we will save the message in this bucket, which is AWS emulator. So just make sure that they are all good, and just to double check that. And then we can check the server. We haven't loaded in yet. For this test, I removed the entire instance and sources from the server. So you need to load entire model. In this case, the healthcare domain. So we have these all required services to test the bucket, and we don't have any instance model here. So we can do the same thing, like deploy all these models from the domain to the service. But in this case, we only have one deployed services because the rest of the two services are under the testers service, which is not automatically deployed. So we have to deploy the service one by one. For now, we have to deploy ORM Center first. Just to make sure that this is pointing at the Word Connect site. Now we are access to the Word Connect, which is connected in here. So the next thing is to send the or test message using ORM Center tester. So as I showed you, I made four test messages and all were sent to the ORM listener. For now, we have four messages because set this one message story to be stored in their site. But what if we decide, I mean, we means the merge connect side, decide to do not save the message at all because this merge connect is just receiving and process something and forward the message to target destination in their system. So it doesn't have any way to retrieve and process something based on the HL7 message. For example, if we go to the here, you can reprocess by using this context menu or just using the left side menu, reprocess message. But what if, as I mentioned, what if this Mirth Connect decide to do not save, which is more secure because this can be accessible from the other person and then can view the messages using this and reprocess message by modifying. So if they decide to do not keep the message from the Mirth Connect standpoint and deploy that, it is still available with the Mirth Connect to the ORM sender. But if you send another four same messages to the EC, but before we move on, is we added that code in the AWS loader. We have four messages in here. So if you remember the key that we specified in the ORM loader, this one, file name, and you'll notice that we actually created the file name like this way. So start with the PID and message processing date. So if we have this kind of messages in the merge connect side, they can reprocess. But what if they decide to not store and there's no way to retrieve from their own way in the merge connect? In that case, we may have to provide a way to resend from our end. So we, although we sent that, if we sent again, let's say there are four messages and let's try again, it will send the same message again. And from the Earth Connect side, they have eight received messages. Actually, only four previously received one messages will be available. So let's say they don't have any way to reprocess the previously sent message from their end. The option is what we can do. So once you look at this, the code in here, we can send the message from the request tab once you select the ORM sender. So this UI, which is the request tab, has a specific button on the right side, which is HL7 Cloud Search plugin. What we did so far was saved the sent message on the cloud service, and then all messages are there. What we need is how to access and read and get selected message from the AWS S3 bucket. So in order to do that, we have a special UI to create the connectivity. But before that, we think about the how we can maintain the user interactive services. As I briefly mentioned, there is a way to access the A- uh, AWS S3 bucket. So if you click here, there is a special pop-up that allows a user to interact with AWS S3 bucket. So there's no plugin here, but this will be populated with the what I'm going to show a little later. Then using this special pop-up, you can directly access and retrieve and even select the specific one to send to the Merge Connect. So to implement that user interactive UI, how can we maintain the services is next thing to consider. So the main purpose is we need to resend the service using that UI. I will show you a little more. But in this case, we may drive a certain way to uh, store that user interactive service in the special way, or we may just keep under the AWS ORM bucket like this way. But for now, we may just create another folder, simply plugin, and then you can just the AWS ORM search plugin as a name. So what actually this service does is if you look at here, create button, and then it will show you familiar UI, which is create service. And if you look at the service type picker, you will see that new option, which is plugin. And the plugin has, for now, only one service, which is HL7 Cloud Search. And you can create the service name like this one, or for, for simple test, you may name like this one. And if you go to the steps, you will see that the commented lines that you have to populate in order to interact with the specific UI. So for now, we have uncommented two lines. And the first line is the list of string. And I may populate this one is a garbage one. It's not actually H7 message, but let's assume that this is the H7 message to be displayed in the that one after retrieving the AWS S3 bucket. So this is quite simple. Even you can add like simple PID value as a user intent interactively typed value, and you can use the even something like this. This is a kind of faking one, but just to show what actually the argument does. And you can, oh, because there's no group, so you have to ignore the group as well. And you will see that this markup plugin is loaded, but there's no way to see that this in the request, even if we specify the PID as a argument, because the argument service should be showed in here. What this means is if you, let me just add another one, same as request listener. Let's say just one ID is required and deploy that. If I deploy this one. This test request listener is visible in the UI, main UI. But this one, AWS DFT markup search plugin, won't be visible in here because this is tied to this plugin button, actually this pop-up. So, and if you see here, there was nothing in the picker, but for now, it has one element, which is AWS DFT markup search plugin. So as I added three records in the list of string, and I put the prefix of the PID. So if I put it here, it's the faking the value. But if I populate this one and click execute, it will show the value like this one. It's pretty user interactive, but not actually uh, that user interactive, but still provide some kind of user interactive as long as you provide what the HL7 cloud search service requires. So this is the just simple one. I don't want this one. So as I did with this some sample one, I can create the this AWS ORM search plugin. But to make the this session shorter, I can import the service from the demo file that I created. So I named as AWS ORM search plugin, and you can follow these steps. But for now, what this service is the same as before as the for the first line. We have to provide this Amazon S3 client instance accessing code, of course, the login code. So, and the next thing is if we look at the here, we can specify certain arguments that can be applied to retrieve the HSM message, and then this argument will act as a filtering tool. So we may provide all of them or one of them or none of them. So I define the PID and date from and date to filter out the HSM message in the bucket. So what actually that means is if you look at here, as I mentioned earlier, each file has two sections. The first one is patient ID. The second one is message.7, which is the message processing date. So we can use that one as a search category. So we are not uh, going to deeper, but for now, just simply look at the here one. This is the what previously uh, shown once you create this plugin, and then it will be shown as a commented line. Then you can provide a bucket, or you may just put the bucket as an argument as well. And then if the bucket is this separate one, like bucket ORM bucket, DFP bucket, or monthly bucket, or something like that, you can specify in this argument as a bucket, something like that, and then you can even access the bucket name, different bucket name using these arguments, because we are using this bucket name in list object v2 request. So it's as long as you specify the bucket as an argument, even if this one can be available here. And then you can retrieve entire the file, but it doesn't mean that entire content, just entire file name. So once you get the object to retrieve this object, you can iterate the entire services by filtering based on the patient ID or date time from to based on the second part of the HL7 message file. So we can use this one to filter out based on the provided PID or date value. And then once the value are filtered, it will get the actual HL7 message content one by one because we're not getting entire messages to the UI. So we can just iterate the filtered list to get each HL7 message from this key, using this key. And then we can assign each HL7 message to the HL7 message string list. And then there is a Maca specific method that associates the value to the with the UI. And then you must set this set the value to set list of strings, especially this one. So this will be automatically generated and commented. So you can just uncomment that. And the only thing is you can just populate the HL7 message and then just do whatever you prefer. I just put add extra line here to populate the result message, which will be shown right below the result. And then just put the how many records are found from the. And then this HL7 Cloud search service will automatically attach to the picker on the pop-up. So you don't have to worry about how to associate. As long as you choose that one, this will be automatically assigned to, oh, I mean, as long as you deploy this service. So let's verify first. So let's load first, then, and we have only one here, plugin. Okay, now we have two plugins under the plugins folder. And if you go to the ORM Center, and especially the request tab, and if you click this HL7 Cloud Search plugin button, and you will see that there are two services are loaded in the picker. So you can choose whatever you prefer, and it will show the required arguments defined in that service. For example, this service requires, the actually requires, may provide, so you may provide or not with three arguments. If you do not provide, based on the code that I added there, it will return entire message. But please make sure that this is just for files. But if you store millions files, it will, be really bad performance work. So please make sure that either you can just create the separate bucket and more granularized bucket to store and just pointing at that bucket. As I mentioned, you can put the bucket name here, and then you can just specify the bucket to locate the specific bucket to narrow down the amount of the searchable data. So we just retrieve entire HL7 method, which is CT001, CT002, CT003, CT004, or just P001 to P004. So you can search the specific one. Yes, we can search that one. So we have the way to retrieve the message from the S3 bucket. But in certain case, even if they can receive the message, but somehow there are some glitches or there are missing feature that is not available soon, or they don't have any resources to implement because they run out of the budget, their budget, or not for this period. In that case, they may need manual update from the sender side, in our case, Maca side. So the scenario is this. The client app wants last week's message that failed in their system. So last week they failed certain because of certain reason, either glitches or some kind of missing condition. But somehow they cannot process the last week. I mean, they only can process this week's date. So let's say I mentioned earlier that the top two records are happening not or happened last week, and these two records happened this week. So if these two messages were not processed in their service, I mean in their channel, if we resend this one as is, they may not process because, as I mentioned, they can process only this week's value. So what they want is we need to populate MSH7 with current 2 weeks, whether this today or yesterday, but current week. So what we can do is maybe you can filter out date first, which was last week. For now, we are not filtering many records, so just can provide just one filtering condition, like the only the last week, because we don't have 2 more weeks data. So we can just use this date two key with this value, and then we can, if we can execute, we can get the two records of the HSL message, and then we can send this one. But after we choose that, we cannot, after we retrieve that, we cannot pass entire message to the main window, which is HL7 uh, pane. So we can do one by one, and we can choose the first one, and then it will be populated in the HL7 message pane. And then what we can do is, based on their requirement, you can change the value, maybe today, and then hit the process, will send to the here. You're not dive too much to the merge side, merge connect side. You can just uh, show how can Macas send by using the cloud service. So we're not handling any logic in here. Just look at the messages sent using this one. So if we click the process, they will receive the message, and receiver will be changed to the night. So we can click the message again, and if you see that here, this is requested by the admin, which is the manually sent after retrieving, and the received count is changed to 9 from 8. This is what we just did. So from the initial requirement that was not available in the previous version, Maka can now send a previously sent message using AWS S3 service, especially in this case by using this MinIO, which is emulating Amazon's S3 storage service. But the way of storing actual HSM message to the Amazon S3 storage service won't be different. So you can keep using this one for testing the storing and retrieving, or even creating bucket or something using the Amazon S3 client object. So by using that, Maka handle all the previously sent message, and then we can easily set, retrieve, and pick and send, and even modify the code to send message to the client based on their requirements. So this is all for today. In next session will be Azure's Blob Service or maybe Google Cloud Storage Service. But please play with this version first, and then if you are pretty familiar with it, and then it'll be very helpful to your work or even your personal testing purpose. So if you have any question or feedback while you're playing with this version, please contact me through this given email address, and I happily respond to you. Thank you for your watching this video, and see you next in session. Thank you, and bye-bye.